model, but not. I mean, that outlier only affect the value of v, okay, in student t distribution, which is good. Okay, which is good. Okay, so the mean and the scale are estimated by weighting more data points from the bulk of the data than those apart from it. So we actually get like the mean and well, the scale actually, as I say, is closer to variance, closer to the standard deviation, more from the data here. Okay, the outliers, I mean, well, they affect, I mean, only the V or nu, okay, in the student t distribution. Okay, so once again, it's important to remember the scale is not the standard deviation. Okay, but the scale is related to the spread of the data. So, when you consider scale is related to the spread of data, it will be similar. It is similar to standard deviation, in certain manner, right? So the lower its value, the more concentrated the distribution. So you can see that, okay, based on this, result, I mean, student t distribution, the scale is very, very similar to standard deviation, okay, in terms of their impact, okay, to the distribution. So for the value of v greater or equal to 2, the value of the scale tends to be pretty close, okay, to the value estimated after removing the outlier, okay. So even if you remove the outlier, okay, the scale tends to be very close. So you can see that, okay, student t distribution is able to handle the outlier, much more robust than the previous model, okay. So rule of thumb, for values of v not too small and taking into account it is not theoretically fully correct, okay. Remember, the model is always an approximation, so it is not, okay, we cannot consider the model is 100% correct anyway. We can consider the scale of a student t distribution as a reasonable practical proxy, okay, for standard deviation of the data after removing outliers, okay. So another type of question that we commonly considered, okay, is like a group comparison. Okay, what is group comparison? Okay, so we may be interested, for example, in how well patients respond to a certain drug. Okay, so in that case, you have like maybe two groups. Okay, one group, do not take. The patient in that one group do not take the drug. The patient in the second group takes that certain drug, and then we compare the response of these two group of patients. Okay, after a period of time. Okay, so this is group comparison, or okay, the reduction of car accidents by the introduction of a new traffic regulation. Okay, for example, like we recently, because we know Taiwan gets a bad name for it's a hell for passengers, right? When we passenger walk on the street, sometimes the cars just, they don't give ways to passengers, right? So recently, government passed regulations, if the car does not give way to a passenger, the driver will be fined, right? Okay, fined heavily, right? I probably should add that. Okay, the driver will be fined heavily. So this is obviously a new traffic regulation, right? So with this traffic regulation, okay, we want to see the reduction of the car accidents. Okay, if like there are fewer number of like pedestrians, be hit by the vehicles, okay, on the street. Okay, we want to observe, okay, if this is the case. Okay, so again, we have two groups. The first group is like before this regulation is in place. Okay, what is the situation? And after we have this regulation, like what is the new situation? So we have these two groups, and we compare to see if this new traffic regulation really has certain, I mean, it really works or not. Okay. So, okay, student performance under different teaching approaches. Okay, I'm here to teach you guys like in person. In some courses, the professor may prefer to teach like online, or some professor even do it like I don't know English term for that. 翻转教室, okay. So I don't know the English term for that. Basically, they just let you watch the video, right? And then they just let you do some practice, in class, right? So the professor may be in the classroom or not, okay. But anyway, that's a different like teaching paradigm, right? But anyway, okay. So there are obviously different teaching paradigms, okay. Of course, for me, I prefer teaching in person, okay. Whether or not student comes to a class or not, that's different issue, okay. I don't care, okay. I prefer to interact with the students directly. But okay, students may perform differently under different teaching paradigm, right? Okay, so for different teaching paradigm, we can observe student performance and see like which teaching paradigm work better, okay, for students. Okay, again, this type of thing, will be considered as a group comparison. When I say group comparison, I'm not restricting to comparing just two groups. It could be multiple groups, like for example, teaching paradigm. Okay, the example I just used, like because obviously you could have more than two different teaching paradigms. Okay, so sometimes this type of question is framed under the hypothesis testing scenario, with the goal of declaring a result statistically significant. Okay, so in the traditional statistics approach, okay, we use normally we use the NHST. Okay, basically we just have a hypothesis, and we just use we just try to see if we can refute, we can dismiss that hypothesis using like the collected data, obviously. So relying only on statistical significance can be problematic for many reasons. First, statistical significance is not equivalent to practical significance. Okay. Second, really small effect can be declared significant, okay, if you collect enough data. But this is not necessarily the case, okay. The third one, okay, idea of hypothesis testing, okay, is connected to the concept p-value. But I'm not sure if I think I mentioned about that, earlier, okay. The p-value that was proposed like in the traditional statistics, by frequentists, basically, has some built-in assumptions, okay. For example, one of them is like tied with like the intention of data collection, which is completely, a lot of times are completely unavailable, okay, when you do data analysis, because a lot of times you get the data from somebody else who collect data for you. But you have no idea how this data was collected. Okay, so because under different intention of the data collection, the p-value can be very different. Okay, did I give you guys an example of that earlier? So for example, like flipping coins. Okay, flipping coins. You say, okay, I got the data. Okay, this coin flipping is like we have like maybe like a 5 head and 10 tails. Okay, 5 head, 10 tails. So you say, oh, so we collect 15 coin flips with 5 head and 10 tails. Okay, if you try to consider all the possibility for 15 flips, that is what? Okay, think about that. That's the whole possibility space, right? Of 15 flips, okay? But this is one intention. It's like, okay, I collect 15 flips, okay? I collect 15 flips, and this is the result. We have 5 heads, 10 tail. This is, okay, the original intention is to collect 15 flips. Another intention is, okay, I collect the data until I get 10 tails. And then the result is where we got 5 heads and 10 tails. These two intentions will impact the computation of p-values. Okay? Depending on what the intention you have. You have like when you collect the data, you have to compute the p-value differently. And obviously, different p-value will impact the hypothesis testing. But when you get this, okay, I got 5 head, 10 tail from some people who do the experiment. Do you know what is the collection intention? When you get the data from somebody else, they may tell you, they may not tell you, right? Because you know the high school math, right? These two cases that I was mentioning, okay, the first one, throw 15 times of the coins, and the result is 5 tail, 10 head. 5 head, 10 tail, I'm sorry. 5 head, 10 tail. This is the first case. The probability, just use probability as example, okay? So what is the probability? So you can calculate that, right? Another case is, I want you to throw until you get 10 tail. And in this case, you got 5 head. I mean, in the process of getting 10 tails. So the probability of these two things are different, right? I mean, well, it's not just determined only by the resulting data set, obviously, right? So that's what I meant by, okay, those intentions, okay, they will impact this p-value computation, and which again will have impact, to your hypothesis testing. So in some cases, okay, you can refute a hypothesis. Some cases you cannot. But those factors are not determined by you, okay, and sometimes you don't have those consideration, those factors at hand when you do the data analysis. So how do you do it? So that will create a problem when you use NHST to deal with group comparison. Okay. So, but the people are used to doing group comparison. I mean, by, for example, NHST, because that's what they learn in most introductory statistical courses. Any statistical courses teach this type of stuff, like as like as an introduction to statistics. I mean, if you take like if you are going to take like a graduate school entrance exam, and it happens that I mean one of the subjects is like statistics. I'm pretty sure, okay, it will cover HST, okay, because this is like one of the fundamental concepts in the introduction to statistics courses, okay. So a lot of people just have studied this thing, and they consider this as like a standard practice, but in Bayesian data analysis, we consider this approach not appropriate, okay? So instead of doing hypothesis testing, okay, so we are going to take different approach, okay? So we are going to focus on estimating the effect size, okay? What is effect size? We need to quantify the difference between two groups, okay? Here, of course, I say difference between two groups. I mean, we can, if you have more than two groups, I remember I just mentioned, I mean, it could be more than two, right? So if you have more than two groups, we can compare, we can do this computation for like every two groups. Okay, I'm not saying this doesn't work for more than two groups. So so just want you to be aware. But every time we just consider two groups. So one advantage of thinking in terms of effect size is that we